Let's learn how to identify a trig function from a sinusoidal graph. So before we advance too far, we need to understand what is a sinusoidal graph. And I am not going to give a worded definition, but instead I am going to give a graphical illustration of what a sinusoidal graph is. So sinusoidal graph is just a graph that appears to be a wave, a simple wave, an up and down wave. As a hand sketch version, it can just simply be a wave up and wave down right here. And of course, being a hand sketch version, then it won't be precise. But now if you look over into my computer screen right here, then this is perfectly a sinusoidal graph. So it's a simple wave, simply just up and down, and all symmetric. There's a center line somewhere that we're gonna learn that skill to identify, and that's all there is. It's a and that's what we call a sinusoidal graph, a very simple wave, up and down, peaking up, peaking down. And so back to our objective here is to identify a trig function from a sinusoidal graph. So think about a sinusoidal graph like what we have on screen here. Then the critical thing to remember about a sinusoidal graph is that the function that gives this graph can be identified as a sine function. Okay, that's one thing. And also a cosine function. So the bottom line is there are two different ways how you can identify the function of one same sinusoidal graph. And that makes perfect sense with our learning, with what we have learned previously about, because once we have learned graphing a sine function or a cosine function, then from the base unit of either a sine function or a cosine function, then once we start replicating the same base unit here, but start replicating infinitely many times here, then we ending up what we so call the complete graph. But then in the end, the complete graph here is what we call the sinusoidal. And so in that case, this one sinusoidal graph can be thought of as the replication of either a sine function or a base unit of a cosine function, and replicate it infinitely many times. And so we will be learning both ways to identify the trig function that gives the same sinusoidal graph. So what anybody needs to understand is that a complete sinusoidal graph here, regardless of being either a sine function or a cosine function, it's always going to have the same center line and an amplitude, how far up and down each way from where the center line is vertically. And what I mean is, before any of us can even identify whether our function that gives this sinusoidal graph is a sine function or a cosine function, before we even identify that, then the wave itself already had a center line and an amplitude. And so now with the grid being displayed along with the axes here, the horizontal axis and the vertical axis, with some labeling on the axis, some scaling labels on the axis, then it's going to be extremely easy to find the amplitude as well as where the center line is before we even have to identify whether it's a sine or cosine. So the usual step here is that anytime we are given a sinusoidal graph, and once we have the grids together with the axis up, we can always first thing identify the center line and the amplitude of the wave, how far up and down vertically from where the center line is each way, without worrying about being a sine and cosine. And once we've got the amplitude up and as well as the center line, then we're going to start identifying being either a sine or cosine depending on how we want to identify it. And so now, to clarify the idea I was saying earlier, let's get to do one problem here. So what we are starting out here as a given sinusoidal graph, simply a graph in a completely blank piece of paper or a blank board, no grids, no axes, no scaling or whatsoever. All we see here is a simple wave in its most simple center here, up and down and up and down. And so immediately, once again, I'm going to see that there has to be a center line somewhere. And of course, it's not the point of how can we precisely put the center line. That's why I'm putting my center line here in dotted line, indicating that there has to be a center line here, or some textbooks call this the midline. But the idea is any simple wave, any sinusoidal graph must have a center line. And from where that center line is, vertically up and down from where the center line is, then it's going to indicate how far your wave goes away from where the vertically from where the center line is, and we call that the wave height or the amplitude. And so now in our current graph right here, once the grids along with the axes are being put in together, and as well as the center line, we already had that previously from the earlier steps right here, and with some scaling, then I can immediately identify that this same graph, as I already made my argument, it could be a sine function, or it could be a cosine function. One same graph, we can express that in two different ways. But to clarify the idea, once again, either being a sine function or expressing that, identifying the function as a cosine function. This graph here, this simple wave, has a center line at, it looks like the line here is y equals 1. So that means either way we're expressing it, it has to be outside of our trig functions, either sine or cosine. It has to be a plus 1. So this is how it's connected to what we've learned about adding a constant to our function is going to change our center line or our midline right here. And once again, back into our graph right here, we can, according to the grid, how the grid is showing, then our sinusoidal graph here has an amplitude. Our simple wave has an amplitude, looks like being 2 vertical units up and down from where the center line is. So that means we find an amplitude here being, and it's okay to use positive value. So that's, I can put a 2 here, or if we're expressing that as a cosine, we can put a 2 here. And so as a generality regarding sine or cosine graph, or in general from any given sinusoidal graph, what I was trying to say is that in either form of a function identified here, then we always going to have an amplitude. For this particular graph, we are going to have an amplitude being 2, regardless whether we're expressing it as a sine function or a cosine function. Amplitude is 2, and we have a center line at y equals 1. And so the same graph there. Now if we want to see that particularly or specifically as a sine function, then to remind yourself the picture first of all. Sine function, the base unit has this picture over here. A wave up, swing down, and hits back to the center line, and center line is exactly in the middle. Then we're going to start identifying the starts and the end of our sine function base unit to formulate the expression where we can put it inside of our sine function. And so having that fundamental shape of the base unit on a sine function here in our mind, then on the actual graph, if we can just simply put a vertical line here at, well, in this case at a negative pi over 6, and put another vertical line at about here, where on this graph it says pi over 2, then that windows between anywhere from minus pi over 6 to pi over 2, inside of that window there, we have a complete base unit of our sine function. We can see this wave as a sine function, and to make it trivial, I am going to put up the actual portion of that, or that base unit in green color right here. Okay, so that's one way I can see it. So now here I can see that the start is at negative pi over 6 and the end is at a pi over 2, and our wave happening inside of this window here, inside of this interval from negative pi over 6 to pi over 2 is a sine wave. Or we can change that to, you can see that I can change my start. I can look at my start here at a pi over 2 and ending at a 7 pi over 6. In that interval, I also have the base unit here does appear to be another sine function, but different start and different ending on that base unit. So pay close attention to where we put down the start and where we put down the end that identify our base units right here. So now in the way how I'm currently explaining, then even deciding to be a sine function, we can have different starting point for our base units, so we have more than one option. I myself usually choose the start point where it's closer to the y-axis. So notice again the y-axis is here. So if we choose a starting point here at pi over 2, positive pi over 2, it's not wrong. But I would personally choose the starting point at negative pi over 6, simply because that starting point is closer to the origin, is closer to the y-axis, compared to if that starting point was at pi over 2. The starting point here is not wrong, but it's just simply further, and it's, like I said, it's only just my choice here. But so for now, choosing as a personal choice here, my start is being at negative pi over 6, and my end of the base unit here is being a pi over 2. Now we can just simply write it down. So this sine wave, and like I said, we purposely want to see this sinusoidal graph as a sine wave. So I'm going to let my start units chosen to be at x equals negative pi over 6. And my end here is at x equals pi over 2. And that means immediately remind yourself that if our base unit has a start at x equals a negative pi over 6, then connecting that with what we've learned in graphing trig function is that this is as the expression inside of our sine function. We're going to have, let's open for ourselves a pair of parentheses here, a sub pair of parentheses. But here inside here, I'm going to need to put x, but plus pi over 6. So the start point, you go there. See, it could be a negative sign here, but we're always going to look at the positive part. And then if it's a negative sign at the start point, and then inside of that linear expression, we're going to go x, but plus b value. And we're almost done. And now having our start nailed down to be at x equals negative pi over 6, and actually being chosen to be at x equals negative pi over 6, and our end right here being at x equals pi over 2, then we can recognize that our periods for this particular graph, the periods for our particular base units here is always rule of thumb, the end minus the start. So pi over 2 is our ending point, minus the start being at negative pi over 6. So let's just do the math here. Calculation comes out to be 8 pi over 12 which in turn reduces to 2 pi over 3. And having our period to be 2 pi over 3, and remind yourself that the period here is being determined by that coefficient in front of our parentheses inside of our sine function. And so, and keeping that number here always a positive number, and so we can do, remind yourself that our period is always the standard 2 pi divided by that number a. Then we're looking at 2 pi over 3 calculated to be our current period to be equals to 2 pi over a, which after solving for a, we're leading to a equals 3. And that number right here is going to be filling in for our function. So our function, final expression of our function, concluded to be a sine function of 3 in parentheses x plus pi over 6 with a coefficient 2 in front of the sine and with a plus 1 after sine function. Or we can also multiply out the 3 for each of our term inside of the sine function, and that's making it 2 sine of 3x plus pi over 2 plus 1. So that's one answer how we can express our function as a sine function. The same graph there, the same sinusoidal graph there, if we now would like to identify that as a cosine function, then the first thing to keep in mind is cosine, ordinary cosine or standard cosine has this shape right here. The base unit of a cosine has this shape right here, almost look like a V shape, and the center line, the horizontal center line is going through just like that. And so think about if we're completing this V shape, if we're replicating this V shape infinitely many times right here, then once again we're coming back with that, we ending up with that complete sinusoidal graph. And then once we have in mind the fundamental shape of our base unit of the cosine function, then we're going to start finding where this base unit start, and as well as the x coordinates where this base units end. And then once again, looking at the graph we have in front of us here on the computer screen with decimals, then if I put a vertical line right at the y-axis and put up another vertical line at 2 pi over 3 right here, then that space between the vertical line on the left being the y-axis and that ending one at the x equals 2 pi over 3, in between that, this portion of our wave right here, and allow me to now put it in a green color, then this portion of the wave in green is exactly looking like that base unit of a cosine graph. And so this can be the start and the end of our base unit on a cosine graph here. Or we can also choose a different we can also put a vertical line to start at x equals 2 pi over 3 and another ending vertical line to be at 4 pi over 3, and in between this window once again we have another portion that looks exactly like the base unit of a cosine function, an ordinary cosine function. And so for myself, then I feel most natural to pick the interval where my start is closest to the y-axis. And so in this case, I choose this interval to be my base unit right here, my interval from 0 to 2 pi over 3 to be my base unit of my cosine function. If this same graph, once again, this same sinusoidal graph has to be identified as a cosine function. And so in that way, obviously, where I put my two vertical lines in defining my start and my end of the base unit on my cosine base unit right here, then the start is at x equals 0, and the end of my base unit here is at x equals 2 pi over 3. And now, since recognizing our start of the base unit being at x equals 0, then we can start formulating our expression inside of our cosine function here by doing x minus the starting point 0. And then, of course, later on it will eventually become just simply x. But what's after this step right here is to find out what coefficient we can put here. Some coefficient a can be put in front of that. And that coefficient here, that coefficient we're waiting for, is closely related to the period of the function. And so, from finding out that our start of the base unit here is at x equals 0 and our end of the base unit is at x equals 2 pi over 3, then period again can be quickly found by 2 pi over 3, which is our end of the base unit, subtract our start of the base unit being 0, and that gives us the total period interval being 2 pi over 3. And once again, remind yourself that period on any cosine function is going to be the standard cosine period 2 pi divided by a, which is that's coefficient a we're putting in front of our x minus the start point. So in this case, what that we're having, then with our periods previously found here being 2 pi over 3, I am now going to set that equals with 2 pi over a as suggested by the formula. Then the solving work of this equation for a right here is going to lead to our a value has to equals 3. And so now this value here can now be changed to 3. And now we are ready to make our final expression of our entire sinusoidal graph expressed as a cosine function. So here 3 multiplied with in parentheses x minus 0 is the same as 3x. And outside of that cosine of x, outside of that cosine 3x, we're going to add 1. So this is going to be our final function. The same sinusoidal graph, but our final function is being identified as a cosine function. And so, as a final concluded generality, a sinusoidal graph on its own pure nature is simply a simple wave up and down and up and down. It can be identified as a sine function, and it can also be identified as a cosine function. It all depends on how we want to see it. And so once the grids and the axes along with axis labels being put up, then the first couple steps, independent from being sine or cosine function, can be done by simply finding the amplitude and the centerline of your sinusoidal graph. And we can see that the centerline is always halfway vertically between the lowest peak and the highest peak. So in a graph like this, one's grids are being put together with the graph. Then with the vertical distance between upper peaks and bottom peaks, amplitude is half of that distance. And the midline is exactly between the upper peaks and the bottom peaks vertically. So the steps finding centerline and finding the amplitude. These two steps can always be found first and completely independent with the function being sine or cosine, because really sine or cosine will have the same amplitude and the same center line. Then after identifying the center line and the amplitude, the next step now is to, depending on whether we want the function as a sine function or the function as a cosine function, then we are going to decide that based on the start and the end of our base unit. And this is also where we can recognize the periods. So along the way, we can also recognize the period. And that's how we can formulate our function. And so, once again, for example, if now putting it all together here, if I put my start is here and my end is here, and my graph in this portion is in green, then this can be seen as a sine function. If I change my start and end to a different place, say for example right here, then I can formulate my same sinusoidal graph, but I can formulate my function or identify my function as a cosine of x, because the fundamental shape that appears inside of this period window is the fundamental shape of that cosine function. Back at that step where we were deciding the start and the end of our base unit to make it a sine function, we could have also chosen our start point to be at pi over 2. And like I said earlier in this video, choosing a starting point is a choice of yours. So here it could have been pi over 2 at the start, and the end here is being, according to the graph, the grid is showing 7 pi over 6. And so if we chose the starting point of our base unit to be at x equals positive pi over 2, then immediately the expression inside of our sine function here is going to become x but minus pi over 2. Then we are going to identify the period as being, once again, 7 pi over 6 minus starts being at positive pi over 2, and we have an entire interval length of being 8 pi over 12 again, and that in turn reduces down to 2 pi over 3. And periods on any sine or cosine function equals to the standard period 2 pi divided by a, the coefficient we are about to recognize. So here maybe I should put an a there. And so that means back in this formula we already calculated our periods according to start and end. Here is a total period of 2 pi over 3. So we're looking at 2 pi over 3 to equals 2 pi over a according to the formula. And that implies that our a value has to be 3 again after solving for this equation. And so now we're going back to this coefficient and fill it in, that it's going to be a 3. So the same sinusoidal graph and the same expression being a sine function, we now can also write it as 2 times sine of 3 in parentheses x minus pi over 2 plus 1. And we can also distribute the common factor 3 inside of our pair of brackets here, and making it 2 sine of 3x minus 3 pi over 2 plus 1. And now back at that step again where we were about to choose the x value of our start and the x value of our end on the base unit of the cosine function. Then choosing x equals 0 that we've seen previously was only a personal choice. I naturally choose the one that closest or being right on the y-axis. But anybody else can choose or could choose, because there has never been a rule about that, and there's no right or wrong about where we choose a starting point. And so, once again, our start here, basically, all we need is to find an x value for our start where we recognize this fundamental shape of a cosine, and then find out where that fundamental shape as a base unit ends on our graph. That's all it needs. So back on the complete sinusoidal graph right here, then somebody can see this as, let me put up that vertical line right here, but where this vertical line is, somebody can see this as the actual start of the base unit for the cosine function, and the end of that base unit is going to be here at 4 pi over 3. So once again, the start here, somebody could see that as the starting of the cosine at 2 pi over 3 and ending of that 2 pi at and ending of that base unit at 4 pi over 3. And so let's go ahead and write it down. So the start could be chosen from beginning to be x equals 2 pi over 3, and the end there could be chosen right from the beginning to be 4 pi over 3. Then once again, as soon as we recognize the start right here, then we can immediately have our expression inside of the cosine function formulated as following. In a subpair of parentheses, x minus 2 pi over 3. And to make it clear for everybody, I'm going to put that the portion inside of the start and the end base unit here in green color. So there's my portion in green color. And so once again, what's waiting ahead here is now to find out what that coefficient in front of the x minus 2 pi over 3 is going to have to be. And that coefficient, once again, is going to be related to our period of the function. And so now, first of all, with the start being decided at 2 pi over 3 and the end of our base unit being decided at x equals 4 pi over 3, then for sure our cosine or our base unit is going to take the length or the total period being, well, rule of thumb, we're going to take 4 pi over 3 being our end of the base unit, subtract 2 pi over 3, our beginning of the base unit. Doing the subtraction, we're going to end into a total period being a 2 pi over 3 again. And then so period on any cosine function is always going to be related to the period of the standard cosine function, 2 pi, and divided by a, the coefficient inside of your cosine function. And now, since we already found our current period for this sinusoidal graph being a 2 pi over 3 period, then I am going to substitute this 2 pi over 3 into my period on the left hand side of this equation. And I'm looking at now 2 pi over 3 is to equals 2 pi over a. And after producing this equation right here, solving that equation is going to end up a equals 3 for us. And so that coefficient a now has value 3 again. And here we have a different form, different expression of our cosine function, and it's a cosine function, but it's being expressed with a different starting point right here. And so doing a little further algebra inside of that expression here, I can just simply go 2 times cosine, and the expression inside, I'm going to go ahead and distribute that 3 to every single term here, leaving me 3x minus 2 pi. And now I can just use a parentheses instead of brackets. And plus 1. And here's another same sinusoidal graph, but another way how I can express my sinusoidal graph as a cosine function.